Let's delve into the Monty Hall problem. It is a probability paradox that stumps even the experts. It is about understanding why switching doors in a game show gives you 2/3 chance of winning. Imagine you are a contestant on a game show. There are 3 doors. Behind one door is a prize and behind the other 2 are goats. You choose a door but you don't open it immediately. The host, who knows where the prize is, opens one of the remaining doors and it always reveals a goat. Then the host offers you a choice. Do you want to switch to the other door? Or stay with your original choice? Now, what is the intuitive answer? Many people think, it doesn't matter. Both remaining doors have a 50% chance. The reasoning is that after the host opens a door, there are only 2 doors left, so each must have a 1/2 probability, right? This is a common misconception. Here is the surprising truth. You should always switch. If you stay with your original choice, you have only a 1/3 chance of winning. But if you switch doors, your odds increase to 2/3. Let's understand why this happens. When you make your initial choice, there is a 1/3 probability that you pick the door with the prize, since only one door out of the 3 has the prize. This means the other 2 doors combined have a 2/3 probability of hiding the prize. The host's action concentrates that 2/3 probability into one door. Let's see a step-by-step example. Suppose the prize is behind door number 1, and you initially choose door number 3. The doors have a gift, a goat, and your choice labeled on them respectively. The host then opens door number 2, which reveals a goat. This leaves you with the option to switch from your initial choice, door number 3, to door number 1. Here is a simple Python simulation to demonstrate the concept. The code randomly assigns the prize behind one of the 3 doors and simulates the game show scenario for a large number of trials. By comparing the win rates of staying versus switching, you can empirically observe that switching doors results in a higher probability of winning. The key takeaway is that information changes probabilities, even when it seems irrelevant. The host's knowledge and constraints concentrate probability in unexpected ways. Always switch, you will win 2 out of 3 times. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.